Okay, the simplest render target we can get, or no, let's start again. How to create a render target, which is a dynamic texture that enables writing to it. Let's create a folder, render targets. And now let's do materials and textures. And there should be, yeah, there's cube render target, there's canvas and 2D array. But out of the screen, you can't see that, sorry for that. But outside of the screen, there is just render target, just like that. And it proposes a name, a new texture render. Let's do a bigger tile. Let's rename it to, I think, I don't know, RT. And for example, scene capture, okay? And if you open this, it looks kinda like a normal, fully black texture. Here we specify the size, but as you can see, it's not imported, it's created dynamically. So if I change the size, it resizes instantly. There's also clear color. This is important. This means what's the default color for this. Pink, for example. So by default, this texture will be pink. Let's set it like that for a while, just that we know. Also, texture have mipmaps. If you need them, you can enable auto-generate mips. It takes some time, but it saves you, rendering performance sometimes. But it depends. If you won't use the render target in any 3D scenarios, then don't use it. But if you will, let's say put it on a TV screen or something, then yeah, why not? Okay, that's it, basically. Now we have it, and we can't do anything about it yet. Roy says that they are late. So what I did for now, Roy, is I right-click materials and textures and render target. And this created this one. I specify its clear color, which is the default color of this texture. That's it, nothing more. And now blueprint, we'll do it later. We'll do a blueprint that writes something custom to the texture. But first, I will show you another trick, the basic use of them. Let's create an actor that captures the scene into the texture. Basically a virtual camera. So, where was it? Visual effects. Reflection capture, no. Cinematic, wait a second. This is all new. No. Is it in all classes then? Scene capture actor, it should be called. Scene capture 2D. Here it is. Let's use it. This is the capture actor. And as you can see, it looks like a camera. Let's place something here. So for example, let's use our meshes here. Okay, cool. And to show you that it's animated, I will use the burning wood. So where is it? Burning wood, material. Here we go. Or hey, come on, animate. Why don't you animate? It should. There's time. Huh. Real time. Why burning? Oh my. That's weird. It did work, right? It worked on the other map. Recent levels, burning wood map. Okay, here it does. I will copy that. Let's go back here. Oh, I can't paste? Oh, I can. Cool. I don't know. Material is burning wood. Nothing fancy. Okay, we have the camera. The scene capture actor, sorry. Put it like that. And, oh, global. Yeah. And it takes a parameter, texture target. So in this texture target, we just select RT scene capture, like this. And can you see what has happened? In the render targets, we can see that it now draws to the texture. You can open even this texture. Here it's cleared because it also contains depth in alpha. Or sky stencil, something like that. So we need to get rid of alpha. Render target RGBA, no. We don't have without A. But there was, I think, a setting. I think there was a setting in this scene capture actor. Basically, it has a lot of settings, and you want to optimize that. Basically, the bigger the render target, but also the more complex the scene, the heavier it is to render it twice or even more. So don't abuse that. Use at max 2 per level or something, and simplify as much as possible. Basically, here you can find where were they? There were settings, what to include and what not. Here, yeah, in the hidden panel, you have general show flags, and for example, you can, for example, disable anti-aliasing, just like that. I can see it's disabled anyway. You can turn off the sky, the atmosphere. For example, if you only want to render some object, for example, for the UI, I don't know, a weapon, then yeah, you can just disable everything and only leave, for example, static meshes, right? Even you can disable certain types of meshes, like nanite meshes, like grass foliage. Also, there was something like, let me find it. Hidden show flags. No. There's a setting, but I can't currently find where, that by default it doesn't include anything, and you have to provide a filter for it in Blueprint, that it only shows specified actors. So very useful for some, 3D view of a weapon in the inventory or stuff like that. But this is good enough, it's already simplified. And also one of the biggest factors is, of course, the resolution. Like so. Less pixels to render and shade, the better. Okay. So this is one basic use of a render target, that you have a camera that draws the scene. Oh yeah, here it is. Primitive render mode, use show only list. You do that, and there is show only actors that becomes enabled, and you have to manually put the actors to include. And that's great. That's great. Normally you can also add them in Blueprint. So you decide if you need something statically, like here, or you just add them through Blueprint. There's also capture every frame. Maybe you don't need that. And then only it will update if you move it. But as you can see, when I stop moving it, it stops updating. When I move it, it does, right? Now it does update, but when I stop it, it stops. This is very useful because it's not only about movement. You can manually call a command to render from Blueprint. So this is very useful if you just want to take a couple of shots or update every 1/10 of a second or something. Otherwise, it will become heavier if your games run faster, paradoxically. Because, for example, if your game manages to run at 120 FPS, this one will also try to update 120 times per second. So sometimes it's better to disable that and just make an event in Blueprint that calls that manually. Okay, so that's it. I only couldn't find the alpha. How to control the alpha. I don't want it to write. But anyway, that's scene capture 2D. Let's close it. Let's make a new one. So materials and textures, render target, RT, and for example, painting. Okay. Now the resolution also will be this, 256. But we'll make this plane render this render target. First, let's use a different clear color so that we are sure that it initialized. All right. Now material. Material. Render target painting. We place it here. And you use it like you would use a standard texture. It's basically a texture in the pipeline. So we drop it like this. And let's say that we will have, I don't know, let's make this only for now R8, so only red. And the clear color will be 0, black for now. Okay. Now here I have this texture, this render target painting. It's not linear color, it's grayscale. Yeah. Okay. Unreal is wondering what percentage of first-time use of render targets is drawing phallic textures. I think this may be a more common thing that you would expect. Mandatory. Roy says, exactly. And now, okay, so I will use that painted render target. We'll paint on it manually. And here I will use it as a mask between two textures. So texture param D, and this will be layer 1, layer, or no, base color 0, base color 1. All right. Let's select a different one. I don't know, maybe bricks. Bricks are cool. And the second one will be some plaster. Okay. And this one will be used to lerp between the first one and the second one. Base color. Cool. What? Should be linear color for the target? No, it should not. R8. Okay, maybe it always needs to be linear color for render targets. I don't know. Yeah, now it works. Okay, and this has to be tiled. So U multiplied by tiling 8 by default. Here and here. Cool. Whoa. Hexadecimal is now following. Thanks for the follow. Have a great time here. Okay, we have that. Now it should mostly display these bricks. Does it? Oh, but it's very bright. Is this texture so bright? Maybe it is. Let's use it. No, it's dark. Ah, linear color. No. Why is it linear? What the hell? It is sRGB. Oh my. That's a problem then. I imported it wrongly, incorrectly. What? Never mind, I won't touch that for now. Let's use a different one. Maybe that one. Let's see. Cool. Good enough. Now just less tiling. Maybe tiling of 2. Or... okay. We have this. Now we would like to paint something on the render target, right? So painting implies that we have our viewport. We want to, from our camera, cast a ray from the direction of the camera in 3D, and whenever it hits something in 3D, we will need to get the coordinates of this point from 0, 1, for example, and here, right? Or 1, 0. Like if this is my UV space, like this, then I would need to find that point in the UV space. That, for example, it may be, I don't know, half 0.3, right? Or something. We don't know yet what. So this is one method of painting. And let's try that. Okay. Now we need a blueprint, because by itself we can't paint, right? So we need a blueprint. Type actor, BP, render target, painting canvas, maybe. Okay, and I will add the static mesh component here. We have default scene root. Let's add the scene, a manual one, replace, and let's add a static. Oh, what's that? No simulation. Static mesh. Okay. And the static mesh will be what I have here. So this floor. Let me copy the mesh type and the mesh material. Oh, come on. Why I can't copy? Cool. And let's place it in the middle. So 200. Great. And I will place that instead of the floor. Delete. Place it here. Location 0. Oh, it's very small. I shouldn't scale that, right? Scaling is bad. I need a bigger mesh, maybe. Template floor. Does it sound good? Nice. Sounds great, not just good. Template floor. Now I need to check the UVs of this thing. So UV channel 0. Oh no, or maybe it's not perfect, but it's good enough. You know, real estate in render targets is expensive, right? So this one may be a little wasteful, but what can you do? Okay, let's check. Yeah, good enough. Now back to our render targets. So I need to detect first the position where the brush was placed. So first I would like to display some sphere on the, let's say, ray from the camera where it collided with the plane. So let's go to event graph. Event tick is what we are interested in. And it will be like that. We need also a reference to the camera. So first, on begin play, I will do get all actors of class, or no, get player, get phone. Oh, come on, get controller, that's what I mean. How to do that? Get player pawn, player controller. But there's also get camera manager, what's that? Player camera manager. And now it gives me what? Get camera. Get camera location and rotation. Sounds good. But I would actually prefer an actual camera. Get transform component. Interesting. Is it transform of the camera? Let's try that. Get forward vector. Oh, sorry. Get forward vector from the camera. And now, on every tick, draw line. Does it draw line? No. Draw debug line. Sounds cool. So line start will be location of the camera. Camera location. No. Get location. Word location. Yeah. Line start. And line end would be the same thing plus this vector multiplied by length. So multiply. Oh, by float. Multiply. I can't multiply by float. Literal float. And I want to multiply this, let's say, by 20 meters. Cool. Oh, nice. And this is added to word location. And we're good. So start is the camera word location, and end is start plus the direction times length. Duration will be for now 2 frames. Thickness 2 centimeters. Color something. Let's try if it works. Yeah, it draws a line from the camera. So that code is good enough. That's good enough. Let's packet this thing. But now we have 2 locations. Okay, let's pack this anyway. Or no pack. Just a comment. Comment will be get start and endpoint start endpoint of array along camera view direction. Cool. Let's add a comment that it's ray length. Start. Ray end Start and end word location. Okay. Now once we have that, we want to trace against the geometry. So line trace by channel, I think. No, channel's visibility. So line trace by profile. There was something else. Line trace for objects. Yeah. And object types. Make array. And only word static, nothing else. We can add more by adding pin, word dynamic, and so on, but no, I only care about word static and skip everything else. Now, start, of course, start, end, of course, end, event tick. Trace complex. It's whether it tests against physics or graphics. We want graphics. Draw debug type. No. Ignore self. Yes. There's out hit. And this boolean means whether it hit anything or not. So only if it hit anything, we would like to draw a debug sphere. For now, draw a debug sphere. For duration, let's say 1/15 for now, just as a test. And let's draw it in the hit. How to do that? Break. Oh yeah. Impact point and location. Location of the hit. So this. And hide everything else. Okay, so if it hit anything, draw a sphere. Let's try. No, it doesn't do anything. Maybe the ray is too short. But having infinite ray is not a good idea. It will be too slow. 100 meters. Now on tick, check for word static. Is it static? It's not, it's movable. Mobility, static. Still nothing. Yeah, you're right, it's not. Something's still wrong. Event graph. Trace complex, forward static, debug draw type. Let's draw. Let's draw for 1/15 of a second. And let's see. It draws something. But it's incorrect. Start and end. Oh my. Now it's okay. So I was getting the vector of direction. Okay, good. But where is the sphere? It had to collide. If there was a hit, then true. Yes. Location of the hit. What's the difference between this and impact point? 1/15. Nope. Oh, it works for the object. Sorry. What I did. Ignore self. No, don't ignore self. actually, I could do, because we now have only one plane. So I could do trace against component, light trace component, static mesh, and only check against my own component, not anything else. I won't need that. Out hit, return value here. Cool. And there's also hit location already available, like this. Let's see. So I replace that with line trace component to only test against my static mesh component, my own. Yep, it works. So we can almost paint, but I would, yeah, I would only like to paint when the mouse is clicked. So go back here, and first, don't even start anything. I mean anything when the mouse is not down. So is button down? Pointer event. Interesting. Input. Pointer event. No. I don't know. Get input. Wait, first let's get player controller. Now input. Get input. Is input key down for the player 0, and key is mouse, left mouse button. Only if it is, then draw. Like so. Let's see. So player controller is input key down. Yep, it doesn't. Now it does. Okay, but I don't see my cursor, so it should be different. It should be like always do, but when it's pressed, then draw a debug sphere. Yellow. When it's not, just draw gray. Gray. Let's see. Working nice. The duration is too long. 160. 160. Okay, the radius is too big, I think, but let's see. Okay, we have that. It's drawing the sphere. Now we need to draw. So the simpler option I will show first is to use, what was it called? Canvas. There was something with canvas. Begin draw to render target. You have to select the atlas. So I will add a variable like painting render target of type render target 2D, I think. And we drop it here. Render target to the object reference is not compatible with texture in the target object reference. What? Get render target. No. Why not? Render target to the texture. Sorry. Yeah. Now it's compatible. Compile. And by default, let's use RT painting. Okay, so when it's on, let's begin drawing. There's our canvas. We have its size and everything. And let's draw a circle. There's circle, polygon, polygon. Number of sides, 16. Render color, white. Screen position. Screen position, that's important. These are UVs multiplied by size, I think. We don't know the UVs yet, but we can get them. Render texture. But why? Texture to use? Yeah, nothing. I don't want to use any texture. The screen position. So basically we need to kind of translate our word position to position within this. For now, for this very, very simple case, we might have used bounding box. So basically read the bounding box of this, remap the point to fit it, and so on. But what we really want to do is project settings and search for UV hit, and there's support UV from hit results. By default, it's off. I've already enabled it in my project. And only this allows you to use find collision UV from the line trace. So I have this enabled. Now let's go here, out hit. Oh, wait a second. There was find collision UV. UV channel, you specify which, and there's the hit. And here you get the UV. So from this UV multiplied by, what is it, vector 2D, size is this, multiplied by size, I think this will give us the screen position we need. I think, or maybe we just need the UV, let's see. Radius is in pixels or what? Let's try 10 by 10 for now. And let's see. We open the target to have it here. Yep, it draws. Like this. Let's not use phallic examples, let's paint something nice. And you can already see this updating. There's no anti-aliasing, but it works. So how do you like that? Of course, there's no undo. We have to exit the game, that's already painted. So as you can see, this stays, and we don't want it to stay. So back here, at the beginning, at begin play, we should take this render target and basically clear it. Clear color. We can take it from the clear color we set. Get clear color, like so. So this erases everything. Let's try now. Play, and yeah, it's erased. Cool. So now, for a better example than this, we may use an actual material to draw this for us. Because this is just a simple polygon, no anti-aliasing, no nothing. But it's already good, right? So instead of drawing this polygon, we'll draw material. Draw material. Like this. This is disconnected. Screen position to render the texture. This time, we won't pass the UVs here. We'll pass it to the material. Here, everything stays like it is. screen size. Do we need that? I think we do. Render material is that thing. Ah, no, it's material with which to draw. Rotation 0, pivot point half. Cool. Let's unconnect this one. And the material itself has to, basically, when we'll have our material, it will have to know the location of the draw, like this. And the distance towards the center, normally it's infinite, right? Distance for every pixel towards this. And we'll need to cut it off at some point. Like that. If this is to be our radius. So we take the distance, and if it's smaller than the radius, then we draw. If not, we don't. So M, and this will be render target, painting. Ah, there's a material there, but it reads the painting. So brush. Okay. I don't remember the type of the material. If it has to be post-process, definitely it has to be unlit. Unlit. But maybe it has to be post-process. I don't know. For now, unlit. Now the texture. First, we need to read the old texture. So, texture. Texture param. And it will be render target. For now, set to nothing. It will be linear color. And it will also take a vector param that will be brush position UV. We will only read this X and Y, no Z, and distance will be calculated. Distance. There's no distance? There is. Distance from this brush position to actual UVs. And now I need also brush radius UV, and we'll set it to, I don't know, 0.05 small, and remap value range. This is my input, the distance. Now let's say that this by default will be half. So we can already see here what will happen. Like so. And now input low, this. Now softness, brush softness. Brush softness, or no, brush hardness. By maximum it can be 0.999. I will show you why. We'll take the brush radius and multiply it by this hardness parameter. For example, 1 by default. No, 0.5 by default. And it will serve like the white point, and brush radius itself as the black point. And the output is 0 to 1. So what it does, this thing is the distance. As you can see, distance is low at the center of this brush position, right? And then it fades into infinity, basically. It increases and increases infinitely. So now here, I remap this to be at maximum radius UV, so brush radius, and it will also have a soft edge. That is this radius, but slightly scaled down. So start previewing. Yeah, you can see that if the hardness was 0.99, it's almost the same as the radius. So white point is very close to the black point, but the good thing is it's still not a hard edge. It's still a little soft, like so. Very good, right? Like this. And the result will be lerp between old render target and some color, like vector param, brush color. Okay, for example, no green. Using this as the alpha. So it will look like that. What's wrong? Error. Default texture. No. RT paint. Yeah. No, not render target. It's not this one. Or is it? Wait a second, what I'm doing? No, wrong. We don't need a texture color. We only need the default painting mask, I think. But we can have color actually, we can. Let's just have alpha here. But can we have alpha in the emissive color? No. How to do that? You know what I'm trying to do. I'm thinking about how to actually draw, but not the texture itself. Just how to draw with some alpha. Okay, no worries now. Render target, this mask, and it will lerp between this and 1. But using this alpha? No, I don't need that. I can just do max. Max of the old one and the new one. So now, start previewing node, you can see that it adds itself to this already painted thing. I could also actually do something like, you know, lerp with 1. It should be smoother than max. From the old one to 1. From the old one to 1 using this brush mask as an alpha. Okay. Yeah. Now back here. We need to draw with this material. So render target brush. Let's draw. I think it won't work because I think we need a copy of this buffer. But let's see. Target is undefined. What's undefined? This? Okay. Cleared. Oh, it draws something. Because we don't pass the brush position. So back here, we not only need to draw, but we also need to pass these UVs. So we can't edit a material because material is a file. So at the beginning, we need to create a material instance. So sequence. Like this. And material, we need to add one. So material, brush material template. Let's use material like this. by default, it will be brush. Okay. And we take it and we create a make dynamic instance. Create dynamic material instance. We create a material instance. So our customizable material just in this blueprint. Creation flags none. What's transient? What is it? Optional name. Brush mat instance. And packet to variable. So brush material instance. I will move some things to a group called settings. So category settings. And the instance will be like a category called state because it's dynamic. This is set by the user, this isn't. Okay, we have our material. Now, upon having a hit, we can take this instance and set vector param value split, and let's set it to the UVs split UVX UVY. We need to check if it found anything. Yeah, I guess. So branch or select float. Select. Or no. We can actually pass the info if anything to float. If anything was hit or not. Basically, if blue will be false, then we shouldn't draw. So target brush and this reroute. Can we add a comment on this? Yeah. So this will be 0 if brush hit any surf, 0 if not. Okay. So basically we will also do a lerp between the result and the old thing if it didn't hit anything. So we want to skip drawing when brush didn't hit any surface. Keep drawing if brush didn't hit any surface. Here. Okay. And all of that will be called brush shape. In UV face. Good. We can try, I think. We have this painting stuff. We're setting the vector and now we can begin to draw. So we are passing the, the UVs of the hit as the brush position. Here. And if it hit anything, it's sent as value B. Let's see. It doesn't work. Okay. Let's print out. Let's take this and let's do print. And print me what you found. So append this and that. Okay, sounds reasonable that at the center we have something like almost half. It sounds good. And it says true when it hit. It doesn't say anything if it didn't. Huh. So it should be good. Now maybe this logic is flawed in the material. Let's skip the last lerp for now. Yeah, now it draws something, but always in the same spot. Like it didn't pass these UVs. It should. Because it does... Ah! Because we're not painting with the material itself. We should paint with the instance. Okay. Still wrong. Now I'm getting worried. We have draw material. We're drawing the instance of the material, which by default is nothing. But is it set here? Yes. We're finding collision UVs. We're setting vector param. Ah, the name. Brush position UV. Was it called like that? Yes. Let's see now. Yay! It works. But it's too dense, as you can see. So we should lower the opacity. And let's go back to material. You can see how beautifully painted it is. Let's go to material. And there is layer between this and 1. So it should be between this and brush opacity. Or no, brush flow, as it's called in Photoshop. Opacity of a single stroke. By default, it will be 0, 1. Let's try now. That's super weird. That only the last stroke makes sense. And then it gets kind of degenerated. Something's wrong with the math, I think, here. Oh my. No. It's a lerp. It should be... It should be brush flow multiplied by the brush mask as the alpha. And B should be 1, I think. I think so. Now it vanishes over time. What am I doing wrong? It's lerping between the old one and 1. But why does it disappear? I'm beginning to think that we may need a copy. Let's try that. Maybe I'm wrong, but let's try. By the way, disabling this print. Because we are reading from the same stuff that we are writing to, and that may be bad. So let's make a render target copy. So painting render target copy. And let's set that to render target. No, it should be every frame, at the beginning of every frame. So sequence. First we need to copy what we had. Okay, but at the very beginning we want to set this copy to a copy of this. So copy. How to do that? Make render target. Render target. Clear, create, create. That sounds good. Okay. Let's create it with the same settings. So get width. What? Get resolution. Get size. Get size. Get format. Get clear. And get auto generate MIPS. Perfect. So we do that. Create a new one and set it to paint render target copy. Now we write to one, but then replace it before we begin reading. Okay, so there is sequence, render target copy. So we should take, we should take paint render target. Is there draw? Begin draw to render target, the main one. Fill it with the copy. So draw texture. 0 size this. I think it'll be okay. Build mode opaque. And that's it. And then we need to end this drawing. So there's begin draw to canvas context. So end draw. So we confirm what we did. This is it. And now we do all what we've done. Hey, hold on. I know you guys can't see anything, but I can neither. So this will be copy the temporary texture to the main one. Right to them. Okay. Here it should be called we can comment it later. There is begin draw to render target. We will draw to the copy. but the material itself will use the main one. So we create the instance of the material, and then we set texture param. It was called render target, and we set it to the main one. So it will read from the main one, but write to the copy. Okay. Here we go. Where is it? Here. Yeah, we draw to the copy. Draw polygon. No. And now there should be and draw canvas to render target. Very good. And at the beginning of the next frame, it should be copied over from the copy to the main one. Let's try. It works, but it's still vanishing. So I'm doing something wrong in the material itself. Render target brush again. I'm reading the render target. I'm multiplying the brush shape with 0.1. So if this is 0 or small, it should wait, saturate. So clump between 0 and 1. No, it should be good. Yay! That was it. We had negative distance. So as you can see, it works. And we have a smooth brush that has varying opacity because its opacity is 0.1. Wait a second. Now the brush is too big. So brush radius will be more like this. And also, I think the flow could be a little bigger. Cool. And while we edit, what? Yes. There should also be a longer draw of the cursor. So here, this thing will be called draw 3D brush cursor. And all this can be named find 3D pane. Find word position for 3D brush on a surface of the painted object. Like this. And this is path UVs of the hit to the material. And this will be draw brush. And what was that? Check if mouse. Check if left mouse is pressed. So as you can see, not too complicated. You have to remember a couple of things, but once you have it, it's quite okay. Samrat says, I come from traditional Java programming background. All the node-based coding goes over my head. Any suggestions where to get started? Where to get started with Blueprint? When they released Unreal Engine 4, there was a great introductory series from Unreal Engine themselves. So look for old things from like 7 years ago or so on their channel. Probably they're also now updated in Unreal Academy, so I will look there. But in general, in Unreal at least, most of these functions are the same as in the C++ API. So you can also start with C++ and just type the same things, like, begin draw something something. When you see the spacebar, it's actually added artificially, like automatically. So most of the stuff has the same name in C++, just without spaces. Someone says, I want to be an environment artist. How much coding am I expected to know? I would say very, very little. If you want to be a technical environment artist, as you kind of already are, as I saw from your material, where you had this layer mixing and so on, then I'd say that this may be a little too much, not necessary, but some basics may be okay. Sometimes you can find my series on techartite.com, basically the ones about tool making, or maybe you've seen them already. These ones, making editor tools, or more even this one, making tools for levels. So this, making tools for levels, as well as, for example, word position effects, these I would recommend for you as an environment artist. This may be useful. Yeah, as Eloy says, some basic blueprinting, basically to find your way around without the need for a programmer all the time. But for harder stuff like this render targets, just go to a programmer. Don't worry, or just buy ready-made plugins, because there is plenty of them on Marketplace. Okay, so let's see what we have. This. Duration of the brush. Duration of the brush, 115. 115. And now. So here it is. We don't have an undo system, and we should be able to eject the camera and paint with just, the mouse moving, but I leave it for you, basically, to build upon this concept. So what do you think? Is it enough for today, for an introduction to render targets? Eloy says, nice, thank you. I can also show you one thing while we are at it, just to sum it up, how to fade over time. And also, I would like to return to this topic to show more things, like fog of war, for example, or damage being added dynamically, like, displacement. Ryan says it was a good explanation. I understand it a bit better now. Okay, cool, thanks. If you also want to know anything right now, let me know. We still have a little bit of time. It was quite fast, actually, as far as our streams go. Okay, fading over time. Let's go back to the brush. And now look, what we did was either take the old one and lerp towards white or red using the brush. But we can also lerp towards 0 over time. So we have this. Let's lerp towards 0 with alpha being delta time. This is very important. Time that passed since the last frame. And we have to pass it manually from Blueprint. So delta time multiplied by vanishing speed, which will be like, I don't know, or vanishing rate. And it will be like, I don't know, 10% of everything per second. So 10 seconds to erase everything. And we can either lerp to 0 or we can subtract. It's up to you. Lerp is becoming slower over time. Subtracting is linear. We may actually try subtract. So subtract this. But as I say, it's up to you. Lerp would never reach actual 0. Subtract and then saturate, which is basically clump from 0 to 1. Only this will go. No, sorry, it has to be here. Because even if we're not painting, it should also decrease like this. Ryan Raps asks, how do you project an image in material using camera position to change its size, for example? So you have two ways. You can either directly use in Blueprint, like we had draw material. You can also have draw texture. And draw a texture, but you then have to provide not only screen size from here, but you also have to provide coordinates, how big it is supposed to be. So there was, where was it? I think it was this, coordinate size and position. So we have to provide that as well, where to draw and how big. So that's one option. You also have rotation, which is very nice. If you want to do something more manual, it will be a rare occasion, but still. Then instead of doing this brush mask, you can just use, you know, texture, but not, where is it? Yeah, by default it's wrapping, so it's repeating itself. So what you would like to do is either to clamp the UVs. So after you have your UVs, you have to scale them. So first you would need to subtract this to get your center of your texture. And then you would do clamp, very small number, and close to 1. 0.99. So that it never repeats itself, it just clamps. And then you use this as UVs and use the result as the brush. So this is how I would do drawing with a texture. But I recommend using Blueprint, this draw texture, because everything is already there. Everything is already there. You can also draw material like that. Oh, Kenshin, you finally caught me in the live stream. Congrats. Nice to see you here. Sure, Diane. Glad to help. Okay, so vanishing over time. Delta time, we need to pass it. Let's pass it from Blueprint. Time since last frame. In seconds. Okay. how much to vanish to black in seconds. No, per second. Cool. And remember to saturate. So we have that. Because with subtracting you may reach negative values. So we have to pass additional parameters. Here we pass the UVs. Now we also need to set that scalar param delta time. You can find it in the event tick here, delta seconds, or just do get delta word delta seconds here. Pass info about how much time passed since last frame. And draw brush. Let's see. We have that. We paint. And as you can see, it's disappearing over time. Is it? Only when I'm holding the mouse. So we should, I think, totally get rid of this is mouse down. And only use it, not use it like that, not like branch. It should be a branch. The color should be a select. Let's get rid of the branch. The color will be a select. Pick A, so when the mouse is down will be yellow. Pick B, when the mouse is not down will be gray. Here. And now also there is, let's make it smaller. Also there is this. So B means if this is active, the brush is active. So let's select either this or 0 if the mouse is not down. So is input key down? If true, then use the value. If not, 0. B equals is brush is painting active. No. Should we draw? One, if yes. Okay. So instead of a branch here, I just have, and the same happens here. I also don't want a branch. Line trace component and boolean. So this is found, no. If hit anything and if found collision UVs. Then convert it to this. No, that's also wrong, wait. Then convert it to, another end with the mouse. So 3 things have to happen for the brush to be, brush B to be 1. It has to hit any surface, collision UVs should be found, and mouse should be down. Then we set 1. And yeah. Yeah, Royces are always past delta time and then do the branches you had. Yeah, but the problem is that I need to update the material anyway to have it, vanishing. So I always need to draw. So I'll only control the alpha of the brush, but the vanishing has to be there. This draw material. Okay. But sure, thanks for asking. Oh, nothing is drawn. Wait, I disconnected something. Ah, this branch. This goes here, I guess. Yeah. Okay, we have it. Cool. Vanishes over time. I can also see... No, it works well. Now I don't hold the mouse. And it vanishes anyway. Okay, here it is. With vanishing, you can already think about how to do, for example, Fog of War from the player.